Welcome in, everybody. Today we have Raul Jordan with us, lead developer at Prysmatic Labs. Also an OG Ethereum developer, has been in the space for quite some time. He comes with tons of wisdom packed in his knapsack. If you have questions, there's going to be tons of time for Q&A. There's a thread in the announcements channel in Discord where we're going to dump our questions. And when it's time for question and answer, I'll go through that thread and cherry pick some questions from there and feed them over to Raul. We'll let Raul take the floor and he'll lead as he likes. We're super excited to have you here. We really appreciate you taking the time. At this point, floor is entirely yours. And I'm just going to shut up and listen.
Thank you, guys. It's a pleasure to be here. Good to meet the cohort. Heard some really amazing stuff about what Shipyard is doing, and just a big fan of just all the new people that are coming into the space. I think there's just so much to see, so much to do, and really a lot to learn. We're constantly learning all the time from the research and all the cool stuff happening, both at the protocol layer and at the application layer. This presentation is more about what are some of the big changes that are coming to the Ethereum blockchain with proof of stake. This summer, we're going to have a pretty big transition where finally Ethereum is upgrading its underlying engine to be more sustainable, secure, and really efficient. So really looking forward to sharing what we put together and all the big things that are on the horizon, because it's going to get pretty crazy. So without further ado, just getting started here. So my name is Raul Jordan. I'm one of the maintainers of Prism, which is a open source client implementation of Ethereum proof of stake. It's currently the most popular client used today to run the blockchain. We started as a group of completely volunteer grassroots open source developers, and it blossomed into this kind of this effort that is now used by many folks, including some of you here. So really thankful for that. And as I was mentioning to the group, it's really awesome that Ethereum has fostered this kind of this community-based development, even at its underlying infrastructure. We have just open source, transparent projects working on this stuff. So yeah, that's kind of where we come from. And specifically what I work on the code base is I work on the consensus mechanism. So how do you reach agreement between a proof of stake validating nodes? And how do you ensure that that is robust, secure, and meets the design requirements that we have for Ethereum? One of the big things that we really care about in Ethereum is we care about the notion of chain liveness. So this means that if there is a global catastrophic event, if like a huge amount of validators or nodes go offline, can the chain continue going? And can it recover? And that's something that we put a lot of effort into. Another design goal is we want to make sure that Ethereum can run on low resource devices. It's very easy to create a blockchain that requires a supercomputer to run and can process a lot of transactions per second, but it's very difficult to actually have strong scalability guarantees while preserving a minimal footprint for people operating the blockchain. So we put a lot of effort into that because we believe the security of the network comes from people being able to run their own node. So that's what one of our goals at Prism is. So today, Ethereum runs proof of work. And it's been powering thousands of applications today. And we're revamping this engine from the ground up. So it's not an easy feat. You guys are probably aware that Ethereum has gone through several upgrades in its history. Many things that add new functionality, add new opcodes to the EVM, improve certain things about gas pricing or transactions. But this is different. We're changing its very underlying engine. And that's not something you can just easily upgrade on the fly. So aside from just doing that, we're also bringing some interesting changes that will make Ethereum even a stronger settlement layer for Web3 in general. And we're going to talk about how this upgrade is actually going to work, right? Cool. So here's how it works. Basically, you have an airplane and you need to switch airplanes mid-flight. It's just not an easy task. So the reason why this analogy comes to mind is because you can't really stop an airplane mid-flight. You can't stop Ethereum while it's powering applications and people are depending on it for transferring value and tell everyone, hey, give us like a few hours to do an upgrade and to do the maintenance. It doesn't work like that. Not only that, but Ethereum is also run by many operators around the world, many of which we don't have control over. We can't just call up a group of people and be like, hey, upgrade your nodes. It needs to be done in a very robust fashion. So it's a very tricky thing to do. And thankfully, over the years, all the research and development has been very transparent. So on GitHub today, you guys can find the actual specification for what is called Ethereum 2.0. It's no longer called Ethereum 2.0. It's now just called Ethereum, but everything happens in the open. You can find it here, specifications to everything from how the upgrade will work, to how validators actually perform their duties, to P2P networking. And this is all open to contributions. A huge wealth of information here. And there are also annotated specifications created by Vitalik and other folks that help explain this to a wider audience. So all of this is open. Okay, so how is this actually going to work? Cool. As mentioned, we could normally do a network upgrade, but proof of stake is so different than what we have today that we need an alternative. It's also a very radical shift to change Ethereum's engine. If we don't have it battle tested or proven, it could kill the network. So how can we make sure that we test this at scale before we actually do this engine switch? So instead, the way it's going to work is we launch a parallel blockchain called the Beacon chain, which runs proof of stake consensus. And then what's going to happen is just like two airplanes flying side by side, we're going to eventually merge them midair. It's pretty interesting analogy. Cool. So this beacon chain, this proof of stake chain is actually live today. It's been live since December 1st of 2020. It's open to anyone to deposit 32 Ether to join the chain as a validator. And it currently secures around $28 billion worth of stake ETH. It's a decent amount of the market cap of ETH, but it's still not as big as we think it will become once proof of stake is completely live for everyone. You can actually see data from this chain on popular block explorers. There's one called Beacon Chain that has a ton of information on the active validators, on performance, on blocks, and what's going on. Keep in mind, today, a lot of people use Etherscan, and Etherscan is adopting a lot of this as well. And it's going to become more prominent after proof of stake is completely here. So it's a great way to peek into the future. Oh, the numbers are a little bit outdated here. But yeah, we do have, it's around less than 10% of the ETH supply, and full proof of stake of the Ethereum chain is going to be coming together early this summer. With both chains running in parallel, we plan to actually merge them together into a single thing. You can see at the top here, we have this, what we call the Ethereum execution layer, which contains accounts, dApps, smart contracts, the Ether that you hold in your wallet, and consensus. And we also run this chain in parallel called the Beacon Chain. At some point this summer, these are going to be merging together, and we're going to continue, people are going to continue running dApps and transactions. And without them really knowing it, the engine underneath it has switched to be the actual Beacon Chain. So we have two pieces of software. We have this idea of a consensus client that runs proof of stake. Well, we have this thing called an execution client, which runs the EVM and transactions. Today, this popular client is Go Ethereum. A lot of folks here run it, use it. If you interact with Ethereum, you probably use Go Ethereum to some capacity. And that's what we call an execution client. And Prism is a consensus client, which is a separate piece of software that actually runs the consensus algorithm for proof of stake. And here's an expanded image of the merge. But things are not stopping. We're not going to pause the chain at any moment in time. Instead, there's going to be this switch of the underlying consensus engine without people really needing to be aware of it, which is awesome. Cool. So here's the two chains running in parallel that we're mentioning today. So on top, we have the current proof of work chain that contains blocks with transactions, right? This is what Ethereum is today. And at the bottom, we have this parallel chain called the Beacon Chain that runs a validator registry and runs proof of stake consensus. At the actual merge, what we're going to be doing is we're going to be merging them together, embedding the blocks from the execution layer into the Beacon Chain. So instead of them running its own chain, they're going to be now part of the single chain that is advancing as one. And that's the key of how the merge will work. So from a user perspective, things will continue being the same. You'll be sending transactions, you'll be using MetaMask, you'll be using your popular applications that you're comfortable with, but the actual engine that runs consensus will look different than it is today. In terms of the architecture of the software that's running this, so you have a beacon node, a consensus client, and you have an execution client, which could be Go Ethereum. So you would envision that you would be running Prism and Go Ethereum side by side, and these are what basically comprise an Ethereum client that runs the actual network itself. What is Ethereum 2.0? Ethereum 2.0 is not a thing. It's just Ethereum. In the past, we used the name Ethereum 2.0 to refer to the set of upgrades that are coming to the chain, including proof of stake and other improvements. But we think there's a lot of confusion here. There is only one single Ethereum, and that's very important to clarify. After the merge, we're going to have the separation of consensus and execution. But from a user perspective, there is and only will be one single Ethereum, which I think is a very special thing. So this new beginning actually lets us add a lot of cool features. It's a fresh start for Ethereum's consensus. So it gives us an opportunity to add things we've wanted for years. We're building this new chain out, gives us a lot of possibilities for things we could add. And some of the things covered in the presentation are actually available today and will be more prominent after the merge. Cool. One thing that's coming is a predictable standard block times. Today, Ethereum block times are probabilistic. And there are times where there can be high variance on this. This can be harmful for user experience, for applications, and for some smart contracts that depend on this. So in Ethereum, and after the merge and proof of stake, block times in Ethereum are fixed 12-second intervals. And we have guaranteed transaction finality enshrined in the protocol. So this means that finality is not just a probabilistic thing, but it's actually something that it's a guaranteed in the protocol if enough validators are participating. And not only that, but we're planning on methods of reaching one slot finality coming to fruition next year, meaning there will be finality every single slot, which is super special. That means that you can have full finality on your transaction literally one block after they happen. And there's a lot of research really going into this. But what's really exciting is having no more variance in block times after the merge. That's very important for developers. Something that's very exciting as well is better randomness. So the way the proof of stake consensus works on Ethereum is it relies on distributed randomness to select the block proposers. So today, to participate in proof of work, you basically run this high power consuming machine that participates in a global competition to decide who gets to select the next block of the chain. Instead, in proof of stake, this is actually assignments are predetermined, and the random seed comes from distributed entropy from the validator set itself. So this is super cool. That means that we can actually expose this to smart contracts with a new opcode called random. Today, there's no really good way to do randomness on chain on Ethereum. Of course, you can't really have smart contracts that depend on this. But after the merge and after this opcode is included in Solidity, for example, you'll be able to use it to power all kinds of new smart contract applications. Even then, the randomness will get even stronger than it is. The Ethereum Foundation and others are actually spending a lot of money on a project called verifiable delay functions, which adds even stronger randomness, meaning that it cannot be really gamed even by people that have very powerful hardware. That's still something that's happening in the background, but something very important for application developers is to watch out for the new random primitives that will come from there. Something I'm personally very excited about that's coming are light clients. So light clients are super neat. They are these very small pieces of software that can track the head of the chain and can verify proofs of the account state. So that means with only a few kilobytes of data per day, like you can actually follow the head of the chain without having to trust anyone. So you don't have to trust a third-party provider. You don't have to trust AWS, Infura, or whatever. This means your browser wallet can actually become a light client itself, and it no longer relies on this. So that really helps us preserve the promise of decentralization. And it's a very strong guarantee that we're providing to developers. So light clients, today we have light clients in Ethereum, but they suck. They are leeches on the network because they demand a lot of data from full nodes, and it's not sustainable. They don't pay for this data. It relies on just honest people that are providing proofs. And it's a dead landscape today. Instead, proof of stake makes them front and center, and they're enshrined in the protocol itself. So it makes it a lot easier to build native light client support. And an interesting analogy is that your MetaMask wallet can then become a light client. To give you an example is, imagine that you want to figure out, hey, what is my USDC balance on something like Optimism or some other application on Ethereum? Your wallet can actually fetch this data and verify Merkle proofs against the beacon state root of Ethereum. So it doesn't need to trust anybody about the data that it's serving you, because it can verify the proofs themselves by following the chain with strong security guarantees. Yeah, so today, of course, the wallets are centralized. When you talk to MetaMask, it goes to Infura, which is likely running on AWS. In the future, wallets themselves will be light clients. So they will actually be connecting to nodes over a P2P network and actually verifying proofs of data for users. And there's some really good work being done on kind of building out kind of a P2P network for state data being transferred around. It's called the Ethereum Portal Network. It's this open source initiative that's happening. What they're trying to build is like standardize the JSON RPC interface for P2P for Ethereum. And that allows you to share state roots and data across light clients. So super cool stuff. Please definitely take a look and follow along. I think it's going to be an exciting time for applications. Another big thing is that sharding is coming. What is this about, and why does it really matter? For application developers, thankfully, you won't really have to think about this. It's not going to be something that matters to your development. However, what's really cool is this adds a lot more data throughput to the chain itself. So Ethereum will be able to process a lot more data on chain securely and without compromising the security. One thing is that layer 2 solutions that scale Ethereum benefit a lot from sharding. So today, solutions such as Optimism, Arbitrum, and ZK Rollups are really cool ideas that what they do is that they only publish batches of transactions to Ethereum for data availability. And with sharding, we have very cheap transactions. So it's something that's extremely exciting. We can get 100x, 1000x reduction in fees with sharding and proof of stake for layer 2 scalability solutions. Today, actually, these L2 solutions, they rely on call data costs for Ethereum, which have a gas cost associated with this. In proof of stake, we're actually working towards a new type of transaction that does not require gas costs for call data. If you're an application developer that kind of wants to use Ethereum as a data availability layer, you're going to have 100x cheaper fees sometime later this year. And the demand for block space keeps growing, right? So even with scaling solutions, it will always keep increasing, and expensive gas fees are a scalability problem. One thing we're excited about is just really improving the amount of throughput the chain can handle while reducing the amount of compromises that makes on security. And one more thing is that there's a lot of strength in numbers in Ethereum. There are many teams working on kind of these different layers. So my team works on a consensus engine that powers proof of stake, but there are other teams that also do the same thing in different programming languages. Super cool. So we primarily write in Go. There are teams writing in Rust, such as Sigma Prime, Nimbus, and Lodestar and TypeScript, Teku in Java. There's a Go Ethereum team writing an execution client, of course, Aragon. So there's a huge emphasis on decentralizing development and not just the protocol itself. I think that's what makes this project very powerful and what makes Ethereum as the credibly neutral settlement layer for Web3 applications. And so we are hiring, of course, we're hiring for software engineering positions. If these interesting protocol challenges excite you, please, happy to chat. We have a lot of cool stuff in the pipeline, and you get to see your work make a huge impact on applications for Ethereum, especially after the merge. Come contribute to help making gas fees 100x cheaper. And I have some contact information here, and I thought I would leave the rest of the room for questions, as I'm sure there might be a lot of things on people's minds, and I just want to chat about anything Ethereum related, protocol related. I'm happy to open up the floor.
All right, cool. First of all, thank you. That was awesome. I've got a list of questions coming in Discord, so I'm just going to start reading through. All right, first one. Can you cryptographically prove that a certain version of a protocol, e.g. Prism, Lodestar, etc., is being run? This would let you verify and incentivize node diversity at the EVM layer. So,
I've heard that question before, actually. It's a good question, but unfortunately, it's not possible because you can just spoof it. You can just say that this is open source software, so it's fully open. There's no secret that you can leverage to make sure that your proof is valid. I can say I can create a fake proof that I'm running Teku and I'm running Prism. So I guess an underlying question in this as well, is there a way to incentivize diversity of clients, right? And for you guys who might be less familiar with this, like it's one risk in Ethereum is that there's an implementation of the protocol that runs like the majority of the network and it has a critical bug. This would be very dangerous because it could lead to just a catastrophic bug that maybe prevents the chain from advancing for some time or leads to even worse loss. So the question is, can we basically incentivize diversity of implementations? There's no way to really guarantee that in the protocol. One thing you can do is what we call anti-correlation incentives. So what that means is that if you're running a validator on Ethereum and you get slashed with a lot of people with you together, your penalties will be harsh. So that prevents a lot of people teaming up, maybe running a lot of validators maliciously to do wrong. But no, to answer the question, there's no way to really enforce client diversity at the protocol layer.
Okay, here's our next question. How does client development differ from other types of software development? What makes it unique to be a client developer?
Excellent question. What's really interesting about this kind of work is you're working in a highly adversarial environment, in an open source environment as well. When you're writing maybe an application at a company, sure, there's a lot of things that you care about: performance, readability, testing, of course. But you don't have to think about the fact that what if an attacker makes it past line 10 of this function? Can they kill a $500 billion network? Like that's a different constraint that you operate with. Also, if there is a bug that is found in production, how do you patch it? If there's a vulnerability or an exploit, your code is open source. If you submit a fix to that bug, people can see what the bug is and they can then exploit it even more. So you're operating on a highly adversarial environment, high risk, and you cannot afford to really break things. I think it enforces a culture of far more sophisticated testing. So we leverage pretty sophisticated end-to-end test suite in our software, where we actually spin up, for all intents and purposes, a full-on network with different implementations of the protocol on every single PR and pre-submit. We also run extensive fuss testing coverage to make sure that we can kind of brute force find any kind of panics or crashes in the software. And there's just a lot really that can be done. Monitoring, instrumentation is key. The biggest thing is really the mindset. You have to understand the risk that every line of code could be introducing into many people. The final thing that's difficult about this is that it's decentralized. So you can't just push out an update and fix all the problems like you can to the App Store, for example, or to a web application. If there's a bug, you need to get everyone to update their software. You can't expect people to do that all the time. So we have to operate under that constraint. So it's high responsibility, but also a lot of fun.
Do you think the consensus code will ever get to a point where it can be formally verified in Coke or whatever makes sense?
Yeah, so we spent a lot of effort, not our team specifically, but the Ethereum Foundation research team has spent a lot of time and effort on making the state transition function for Ethereum proof of stake as concise and as pure as possible. And I think the final goal will be some kind of formal verification. So you can find this in the consensus specifications repo on GitHub, but the whole state transition function, basically you have a pre-state and a block and you produce a post-state. That's a pure function and it has a series of steps that must be followed. So I think that can be formally verified. There have been some efforts to work on some parts of it, but it's still a pretty difficult effort. But we do think that it has become pretty concise. So it can be expressed in under 1,000 words.
So following up on what makes it different to be a client developer, what are the traits of a good node client developer that you would look for if you were looking for one?
So one thing really is curiosity and open mindset. There's a lot to be learned from the other teams that are working on similar software. I think one thing is we operate with a design-centered mindset first. We tend to write design docs before we write any line of code, just because the stakes are so high. Analyze all the trade-offs possible and understand sometimes which trade-offs might not seem, like at the beginning might not seem worthwhile, but are something that might just be the best we can do. So sometimes we have to take the performance hit because we can't afford the security or the security risks that a certain feature might. So really just having an open mindset, being a design-oriented software engineer, just being curious about the different layers of the stack. There's so much to learn, right? And I think no single person can really master all of it. So for example, there's the P2P networking layer is its whole beast. There's a lot to learn there. The cryptography, right, can be a black box to a lot of folks. And to myself included, I'm not a cryptographer by any means. So understanding how to navigate the complexity of the different layers and learn from others is really key. I think that's why it's really exciting. It's just this huge rabbit hole of knowledge that you can learn from.
I have a fun one now. What's the thorniest technical problem you've had to work on with Prism?
We have a few, actually. We've had a few incidents and actually some that happened on mainnet. There's two bugs that I think are interesting learning experiences I'd like to share. So one of them actually happened on a testnet. What happened was that And this is actually it seems very innocuous, but it ended up being very catastrophic. So Ethereum is Ethereum proof of stake is a synchronous protocol, meaning that it depends on the concept of time very strongly. So like I said, blocks are supposed to happen every 12 seconds based on the clock, and assignments are predetermined at certain intervals. So what we were thinking is to make things safer for people, we wanted to help adjust their clocks in case they were off by a little bit to make sure that they're aligned. So if your clock is off by a little bit, we would add a little bit of an offset to make sure that you are in line with the protocol. But people's clocks go off sync for various reasons. Maybe their computers get messed up or whatever. Maybe they need a software upgrade or whatnot. So we did that, and we were leveraging a few tools. We were using a different combination of servers from Cloudflare to help sync up people's clocks. There was one issue where Cloudflare's NTP servers had a bug where basically they were reporting that people's time was 6 hours ahead of what it should have been. So what happened was that all of the nodes in the network were thinking that they were 6 hours into the future, and they were producing bad data. And this led to a cascading fault where 6 hours later, after 6 hours of real time passed, the protocol thought that they produced double blocks. So there was a mass set of slashings. So in Ethereum proof of stake, if you produce conflicting blocks, you get slashed. Basically, you get kicked out of the validator registry. So we had a cascading effect of like thousands and thousands of slashings. We had massive issues, forks, reorgs all over the place because we had a centralization vector. We were using these Cloudflare NTP servers for syncing people's time. So that's a huge lesson learned. And any kind of point of failure like that must be eliminated. So thankfully that didn't happen on. The second bug that we learned from a lot was a bug on mainnet actually. And we wrote a report about this. So we can maybe share that in the chat. I can share that with you guys afterwards, but it's super interesting. What happened was, to become a validator in Ethereum, you deposit 32 ETH into the smart contract called the validator deposit contract. And the way it works is that the software, Prism, listens to logs from Solidity, from the smart contract, to verify that a new validator has been inducted. And it runs through a small little voting algorithm to make sure that we're voting on the correct block hash of the Ethereum chain to make sure that there's no reorg that can mess things up. What happened was we noticed that Prism nodes were voting on the incorrect data, and it was leading to some crazy situations where we couldn't figure out new validator deposits. It turns out it was a serious bug that we had on our end with respect to caching. So we had a cache that was being hit incorrectly for this voting algorithm. And we got very lucky because if we finalize if we finalize a majority of invalid votes, then no more validators could ever join ETH2 at that point. So we got super lucky. That voting algorithm didn't reach a majority threshold. So that was really difficult to debug because we didn't have anything to work with. All we had was that we're voting on an invalid block hash. How is it being where does that come from? And when you're looking at a bunch of hex strings, you don't really have any clue. They're opaque. You don't know what they mean. All you have is a hex string that is bad and one that is right. And where does this come from? We tried all kinds of things. We even reached out to the authors of the Go programming language because we were convinced it was a bug in like their binary search algorithm. And it was crazy. It was like around 72 hours of debugging by the team, and we finally figured it out. So we have a report on this. Happy to share with you guys after the call. It's pretty interesting. The fix was also hard because we had to make sure that we communicated it properly. And like I said, it's just open source client development is tricky.
What was it like emotionally the moment that you realized that bug existed? When either someone told you or you noticed, how did you feel in those 5 minutes?
Yeah, happy that we found it, of course. But also the next step was like, how are we going to patch this? How do you fix it? How do you get people to upgrade their software? How do we pray that it doesn't reach an invalid voting threshold? So just a lot of things going through our minds. We focus a lot on like post-mortem analysis. So every incident that happens, we make sure to write up a detailed report of what happened, where we got lucky and how we fixed it. So we learn from that. But thankfully, the community has been super receptive, super helpful. And I think there's just a lot of people that are looking at this stuff and it's exciting.
All right, we have another one. This one says, how advanced of a Solidity developer do you need to be in order to write Prism code?
Great question. So Solidity is a language that you use to write smart contracts on Ethereum. And these are applications on Ethereum. And Ethereum itself is the underlying software that powers the smart contract. So it's like the operating system. And like the code that we write is like the operating system code. We don't really write the application layer code. So you don't need any Solidity knowledge at all to contribute to Ethereum, which is interesting. I do think that to write Solidity code, it does benefit you to have an understanding of Ethereum's underlying client software. So it doesn't go both ways, but I do think that in Solidity, it's very important that you understand the EVM semantics, you understand how execution works, you understand the programming model. And understanding how Ethereum actually processes Solidity code and compiled smart contracts is very important towards informing your journey as a Solidity developer. A lot of bugs, such as reentrancy, surface from the way the EVM works. It's not just a Solidity thing. It's like an underlying way of how Ethereum's programming model works. So no Solidity to contribute to Prism or to Ethereum, but yes, would recommend Ethereum consensus knowledge or protocol knowledge to become a strong Solidity developer.
Basically, the short version is that Ethereum works on like hex code. It works on what Solidity compiles down to. It doesn't work on
Yeah, Prism is written in Go. Ethereum is written in Go. There's clients in Rust, in Java, and even in TypeScript. Like you'll find all kinds of stuff, but all of them are more like they're like these full servers that run P2P networking, consensus, databases, embedded databases, things like that. So yeah, just a lot of different parts to the stack.
Next question is opinionated, but the question is, what do you think are the benefits of deflationary ETH? To our question asker, this seems like maybe a bad idea. So they're curious about the positive effects.
So the negative effects of deflationary ETH are interesting. I don't have a strong opinion about where it could lead to for applications, because I think there's a lot of complexity in the macro that happens there. I think what I'm more excited about is having a more predictable monetary policy. So I think it's no secret that Ethereum has changed its monetary policy throughout its lifetime, and that's been a major criticism of the project. I want to say that we're at a point where we no longer have a group of 5 or 6 people on a Zoom call that are like deciding the future of Ethereum's consensus or core protocol code. We have a wide array of teams that each implement the protocol, and there is no boss. There is no like CEO of Ethereum. I think the monetary policy, that will not happen again, and it cannot change unless there's a majority community consensus. I think development is very decentralized and governance is very decentralized at this point. So what I'll say is that I think what I like is we have a more well-defined and predictable monetary policy, and I think that's a good thing. I don't know whether the deflationary aspect will be good over the long-term macro outlook or bad. I don't have an insight there. But over the short term, I think it's bullish. I think it's exciting. I think it's more predictable. And yeah.
Okay. Next one says, was the execution and consensus always separated out? I was of the view that they're intertwined. If they are separated, how are they separated out in ETH2?
Sure. So today, basically, it's a single piece of software called Go Ethereum that runs the whole Ethereum protocol. It runs the transaction pool, P2P networking, the consensus algorithm, and mining, of course, proof of work. And it also has an EVM a VM that runs EVM bytecode. Yeah, actually, you can separate out a lot of these components because each of them has its own responsibility, and you can separate out the responsibilities. In Ethereum 2, the way it's going to be different is Go Ethereum will continue to be the software that runs smart contracts and transactions. And Prism will actually be running the actual validator proof of stake consensus. They connect via an RPC interface. So HTTP, JSON, or IPC, or anything else that you prefer. So the way it works is that you send a transaction to an Ethereum node, it runs the EVM bytecode, it gets packed into a block, and then it gets sent over to Prism. And Prism kind of runs the proof of stake consensus algorithm with all the validators in the network. And it decides that it should be the next head of the chain. So yeah, the 2 pieces of software have different responsibilities. Go Ethereum runs the EVM and transactions. Prism actually runs consensus on the blocks that contain those transactions.
Cool. One more question from that individual. Why did Prysmatic Labs choose Go over Rust, which is considered better and safer by some for systems engineering?
Excellent question here. I like Rust a lot. I want to say a few things about the design rationale here. I think that software engineering is more than just the benefits that you get from a programming language. It's also like the benefits that you get from working in a team environment and an open source environment. I think Go is one of the most concise and simple languages that has a simplest surface area for teams to work with together. When you work, it's very strict about how its syntax works. It's very strict about how to do things. And it's very simple about how to do things. So it makes it very easy to work in a team environment to build software that's proven. Go powers a huge amount of the modern cloud today. It runs the Ethereum network today, which is battle tested for over 7 years. It runs the majority of cloud services on the internet today. It powers things such as Kubernetes and all kinds of applications. And I would argue it does so safely. So you can also write bad Rust code, and you can also write bad Go code. It's true that Rust does make it harder for you to write. It makes it almost impossible for you to write memory unsafe code. So that's one benefit. But we do think that Go is unparalleled when it comes to its networking and asynchronous programming model. It's very strong. It's very easy to write network services. And if you think about it, what is a blockchain node? It's a network service. It's a network server that's talking to other servers on the internet. So it's a combination of simplicity of the tooling that comes with it, the fact that it's battle tested and it works. I think Rust is changing a lot. There are a lot of things that are still on the nightly kind of branch and not the stable branch. It's possible that Rust code in 2 to 3 years will be very different than the Rust code that you see today. Whereas the Go team has made a strong promise of backwards compatibility. Go as a language promises to be backwards compatible in its 1.0 versions. And it's maintained that promise for many years. So just pragmatic reasons, really. Yeah.
Next question. We're going to switch the focus over to light clients for a moment. What are the implications of light clients on orgs like Infura and Alchemy? Are they doomed?
So not immediately. I think it's going to take some time. The reason is that, okay, cool, we have light clients now, but then you need a whole P2P network or a whole set of data providers that will provide data and proofs to these light clients to be verified. So that's what the Ethereum portal network is working on. They're trying to build like this altruistic network of state data providers. And that's a whole beast. Ethereum account state. How do we maintain that over the long term? Who serves that? Who provides it? I think they can definitely switch to being data providers, but they will no longer be relied on for everything. So meaning that basically when you're interacting with Ethereum, you're interacting with Infura. Not necessarily, you're interacting with other network nodes that have strong security guarantees. And you can get user data from Infura, but you don't have to trust Infura because they can provide you state proofs of that data. So it reduces trust. I think they're going to be around for a while because that initiative still has to materialize and it's going to take some time. But I do think that those servers are doomed as trusted data providers over the long run.
Very interesting. Okay. Next question is about RANDAO. What cryptographic assumptions are needed to prove that RANDAO is secure?
Sure. So RANDAO, unfortunately, is still not the best because, so for those unfamiliar, RANDAO is like the randomness commit reveal scheme that is used to select validators in proof of stake. And the way it works is every validator produces a block, and we use a little bit of entropy from that validator to, produce the next set of assignments. So every validator contributes some entropy to a random seed that is then used to select the next block proposers. So it's like this game of random numbers that allows to preserve this random shuffling of validators across the validator registry. It suffers a problem of called the last revealer attack. So like the person that is revealing the next bit of entropy has power over the last few people about what they choose to reveal. So it falls under that same line of criticisms of commit reveal schemes that you find in cryptography. One solution is what the Ethereum Foundation is working on, which is like this called verifiable delay functions called BDFs, which is why they're putting a lot of money on the line to implement this thing. So it's gonna make it impossible for somebody to gain the randomness, even with a strong machine. I think this is still further away, but I think what we're getting with RANDAO is orders of magnitude better than the randomness that you can get today on Ethereum, which is much better.
Just a question about that scheme, because if it goes too deep, we should skip it because there are great questions later. But I thought the way that commit reveal schemes worked was that it didn't matter who was the last revealer, because like within an epoch, you make your hashed commitments and then no one can tell what the pre-images are, and you combine the pre-images in some way.
Yeah, I think it's the last revealer in an epoch has some amount of power that given some conditions, they can cause some harm. So I'm not an expert at this, so I don't want to give you guys wrong information, but I do know that there are some criticisms regarding the commit reveal scheme here. I know there are some problems with it.
This next question comes from a current student. If you were going to start a company betting on ETH2 being a big success, what kind of company would it be?
Sure. So me personally, or like in general, if somebody were to do that, sure. I think L2s are the future. I think what ETH2 enables, what Ethereum proof of stake and sharding enables is really this set of primitives that make scalability of Ethereum a lot more feasible. And I think that layer 2 solutions such as optimistic rollups, CK rollups are the future of this. And so there's two angles. You can either build something for staking. So if staking will become a bigger business than it is today, and there's a lot of players already in that space, but if you can find a unique angle there, I think that's very strong. There's people tackling like lowering the barrier to entry for regular people to stake. So right now you need 32 ETH, which is a lot of money. Can you do it with less? So there's projects like Rocket Pool, Lido that make it easier for people to stake with less money. And there's projects that are tackling institutional stakers. So how can we bring more capital to stake on ETH? That's something that, could be an interesting business opportunity. Like one thing that's exciting about staking on Ethereum is within the risk scope of Ethereum, it's the staking return is the risk-free return that you can get on ETH, right? Any other return that is greater than that provided by applications incurs extra risk. But assuming the base protocol risk, it's the risk-free rate of return of Ethereum, which could be an appreciating asset over the long term. So staking is a business. Building a really strong, powerful L2 that eventually maybe has a token could be, there's a lot of opportunity in the scalability aspect. We definitely think about this stuff and we're excited to see what comes next.
All right, here's a fun one. How can Prism handle the same rate of transactions per second as a company like Visa? Or how do we get there?
So the cool thing is that it's not just Prism, but it's Ethereum as a whole, as a network. How can it handle that transaction load? And the answer to that is that there's different ways to scale. There's like this vertical scaling where you just throw more resources at a problem. Like you can say something like, okay, let's make it so that you need a supercomputer, or let's say you need like 256 gigs of RAM, and maybe you need like a crazy amount of cores to run. And then cool, now we get 1,000 transactions per second or more or whatever. That's the approach that a lot of chains are taking. They're trying to have very high hardware requirements, especially in bandwidth. to even reach like even an order to orders of magnitude more than Ethereum. I'm not going to say any names, but yeah, so that's one thing you could do. But at the end of the day, you're still limited because you know how big your requirements are going to keep getting bigger. In Ethereum, we're not focusing on vertical scaling. We're actually focusing on like network scaling as a whole via data throughput. So with sharding, what sharding allows you to do is it allows the network as a whole to process a lot of data, but no single node has to process the data. So if you're running a node at home, you don't need to process like tens of thousands of transactions per second. You only need to run a certain fraction of those. And together as a whole, the network processes a large amount. So with sharding, we split the responsibility of processing across nodes in the network. And that's how you scale. Like a single node only does a little bit, but all of them together contribute to a huge transaction per second count. And the way to do it really, like,
is it correct to call that parallelism?
in a way, yes, I think, but yeah, you can call it parallelism, but really that's also, I think, not the best way to get there because you're still going to be hitting some limits. The best way is really with layer 2 solutions, which kind of push scalability off chain, and they push transaction processing off chain and only commit certain things to the chain that can then be proven. So with zero knowledge proofs, you can do some really cool stuff where you can do as many transactions as you want offline. You can do, I don't know, 1 million transactions per second, something stupid, whatever. And all you do is that you commit a proof that those transactions are valid to the chain, and that can be verified by everyone. So in constant time, so people can quickly verify that the transactions were valid, and you can have as much scalability as you want off chain. So that's one approach. And I think really that's how Ethereum scales. It scales through layer 2 solutions.
Okay. We've got 4 minutes left. I think we can grab 2 more of these questions. Is VDF already fully part of ETH2, or will it be incrementally improved and added into ETH2? Also, what are the attack vectors to bias a validator is always being chosen? Let's start with the first part.
Sure. No, it is not part of it today. It doesn't need to be. Thankfully, the RANDAO that we have is decent enough for our purposes. And yeah, it will be incrementally added. It's still something that's being worked on. And I think it's still an open competition for anyone that wants to work on that problem. There's a lot of money on the line for somebody that can develop something like that. So no, it's not added. And in terms of to bias the randomness to get selected every time. So to break the randomness here, I think you would need control of a huge amount of the validator set. And at that point, you can already do a lot of damage. So I think other attack vectors pop up. If you control like a third, like maybe a third or more, or like 2/3 of the validator set, you can do a lot of damage. One misconception that a lot of people have is if somebody controls the majority of the stake, can they do anything? Can they like shut down? Can they like delete accounts? Can they revert the chain history? Can they give themselves 1 billion ETH or something? And the answer is no, they cannot do that because the network is powered by full nodes that run the protocol. So if you try to go against the protocol, you will be forked out of the protocol. And I think that's very powerful. What you could do if you control a large amount of validators is you could get selected again to propose and do all that kind of stuff. And you could basically make the chain very hard to use. You can censor transactions if you want, but you can't delete history. You can't really mess things up like that. And also what's really cool about proof of stake is that if there is a big attack like that, so if somebody is attacking the chain with a huge amount of the money at stake, the community as a whole can coordinate to fork them out. So we can all coordinate to let's kick this person out and assume that they never did the attack. So then all of a sudden that person's money becomes worthless. They spent all that money to do nothing and they're back to square one. Whereas in proof of work, they still have mining equipment they can use to keep attacking.
Okay, we have 1 question left and 1 minute left. Recently, I talked with a Bitcoin maxi about proof of stake, and he was very wary due to the complexity that it won't work. Do you have any positive response?
That just means there could be a negative response, which is just vindictive tribalism, but a kind, measured response to something like that.
I agree. Complexity is, I think, the biggest argument against proof of stake. And the reason why it's a big argument is because proof of stake does depend on some initial parameter for it to work as expected. So like you need to select a set of parameters of the chain configuration for it to work. I am not a fan of proof of stake chains that launch with proof of stake. I think what's really powerful about Ethereum is that it is proof of work today and it's transitioning to proof of stake. So I think that resolves a lot of problems. One of the concerns is the nothing at stake is if you launch a proof of stake chain from scratch, you're telling me, I think the argument that person is telling you is that, oh, you're telling me that I should stake these things that are supposed to have value by virtue of them having value. So it's like a tautology. And that's why they're worried that it's broken, because fundamentally the economics are broken. Like you're supposed to be worried about losing something that is supposed to have money because you're using it. So I think it's different in Ethereum. Ethereum has value. It's perceived to have value by society. Applications use it. Has a long history of proof of work already. And in this transition, I think those concerns are lesser than if we were starting from proof of stake in the very beginning. So I agree with the sentiment that complexity is a criticism of proof of stake, but I do think that it's been managed decently well with the latest iteration.
We've managed to hit all the questions in the list exactly on time. So at this point, I just want to say, Raul, thank you so much for coming out and for sharing this time with us. Like everyone in the room learned a whole lot just from your presence. So we appreciate you a whole lot, and you are absolutely invited to come back anytime that you want.
Really great questions from the audience. I was super impressed. Really great to meet you all, and best of luck on everything. Reach out if you want to chat anything about contributing to the stuff, learning more about protocol development, just anything, just send me a note. Really appreciate it.
Thank you so much.
Thank you, Raul.
Thank you.
Awesome.
Thank you.
Thank you.
Thank you.
Yeah.